In order to create such a screen, you just have to write a small script. And this tool is multi-platform. This tool works for Unix. So once we create it for Windows, it works automatically for Unix. And this is what gives us so much flexibility in network management. Okay, this is what the difference between us and other companies. Another difference, what is specific about us, it's real multi-platform. Can you find another company with such a list of the platforms which support so many platforms? Standard. It means that we don't dictate to user what to use. User dictate us, because he already has his network management environment. Okay, we don't say him you must buy HP OpenView, for example. Some companies will tell you, please, in order to use our network management, please buy HP OpenView. Okay, we don't have such a situation. Or another company tell you, please buy Castle as an NPC. We don't say you. If you have and you want to use it, you have such a possibility inside. But if you don't have, use our standalone. Okay, which is, as you can see, is pretty powerful. With the maps, all the mapping features, it has even some features which all these guys, HP OpenView and SNMPC, of course they have a lot of more, some things more, okay, than our standalone. But it has some features they do not have, okay. This is the answer about what is specific about network management. So the first thing is real flexibility, and this flexibility, and actually for big customers we also may consider such a things like adopt for their needs, just to change something. For example, we are OEMing, probably you know, we are OEMing our switches to Fujitsu. Okay, we create network management for them. It looks like Fujitsu. It's everything inside. It's Fujitsu brand, and this application works under HP OpenView network management. It's called with Fujitsu, but actually it's our Megavision inside. It's just OEM'd and customized for Fujitsu. And we passed the quality assurance test in Fujitsu and with this application, but it is another story. Okay. And some other companies like Digital, Olicom, they all have we customize our application for them, and they are using this application, of course, with their name. When you double click on our device inside the application, you will see the Fujitsu here, and not NBase. Okay. Yes, yes, and all this stuff. This is what you see the NBase version, but we also have so-called customized versions for our users. Actually, it's not important, but what it shows just that we are very flexible for big customers. If a customer is real big, we will do what he wants. Okay. And this is pretty old page. I believe it's better to see the evolution of the Megavision, how it is. You just go look. I will show you. This is our site, and you just solutions, and you go here. Oh no, it's not here. It's product lines, software solutions, and you see Megavision here. And the most important thing that everybody likes to see is download the Megavision demo. Demo is very easy to use, very easy to install, any Windows, and you have all the pictures in demo, everything. Just demo. You don't need network for the demo. This is how I'll show you how demo works. This is demo. See, this is demo. Okay, it's just everything is blinking, everything is working. Okay, but it's actually the numbers are not correct because it's just demo. And you do the same thing. You just double click on any device, and you go inside any CNC, you see it started okay, jumping. It's not the good numbers, but it shows you the capabilities. Okay, and it's really easy to install, and you can see the how it, you may see the because the demo it goes every second. I don't care here about network overloading. Okay, just to show the dynamic picture, and you may change. Okay. So our website and our demo is a good, and our website is also shows. Our website is also shows you everything, all the platforms, and it shows you the version evaluation. We release new version and we put the new features which are inside. Okay. I believe I didn't show you the full functionality because I don't remember now. There's a lot of things for a lot of devices and a lot of features and a lot of like filtering and all these VLANs and every device has some features of its own, and it comes with TFTP server which shows which helps. You see, you may. It's demo. Sorry, it's demo. This is the real one now, okay? And it comes with TFTP server. You may download the new agent software. You may download the parameters using via TFTP to the device, and using this. That's it.
Okay, so let me talk about topics involving direct IP or IP switching, layer 3 switching as the NBase concept. Under direct IP, there are a few subtopics. First, I'll talk in general about direct IP. Then I'll talk a little bit about direct IP security. Talk a little about direct IP versus routing, and I will talk about DHCP and direct IP. Not a good acronym. Okay. So let me start with a general overview of direct IP. Direct IP is a methodology by which you have clients on a network using IP, etc., and the clients communicate with each other across direct IP switches instead of routers. Okay? So in the simplest case, you have a network like this where several clients are connected together, and there's some network of direct IP switches to which the clients are connected. And it's the responsibility of the direct IP switches to make sure that this client can communicate with this client or not, depending on the software configuration and security, etc., etc. Okay? Now, how do we do this? It's actually quite a simple mechanism. In essence, all we do is we process inbound ARP frames. Okay? In any IP connectivity, the data path in general looks like this. If we have station A and station B, the first thing that happens is station A will issue an ARP for station B. So this is a request. Okay? Station B will then issue a response to station A. The purpose of this exchange is because we know the IP address of these stations, but what we don't know is the hardware address. Okay? And the purpose of ARP, or Address Resolution Protocol, is to allow the two devices to know their respective hardware addresses. So device A will send an ARP request to device B will respond, and now device A has all the information, as does device B. And so now we will send data bidirectionally. Okay? This is the general IP traffic concept without a router on a local network. Okay? If we introduce a router, the change is actually not so difficult. We have station A typically sends an ARP request to the router because station A knows that station B is remote via IP protocols, via configuration, whatever it is. Station B is located across a router, so station A issues an ARP for the router. The router will respond to the ARP, and the station will send data to the router, addressed, of course, for station B. Now at this point, the router takes over as a sort of proxy station and issues an ARP for station B just as a normal host would. B, of course, replies to the ARP request, and then the router forwards the data along to the end station, or the next router, or whatever the case may be. Station B, of course, responds via IP directly to station A, but the frame goes to the router, and the router forwards it on to its final destination. Okay? And we see that in general, every frame must pass from station A to the router, be processed at the router, and finally passed along to station B, back and forth. Okay? By definition, more processing is done on the frame, so if we can simplify this process somehow, then perhaps we can increase the throughput on the network. This is the design of direct IP. So in direct IP, what is the change in behavior? In direct IP, we see the same sort of beginning. Oops. Except that the station A will issue an ARP directly for station B. The direct IP will intercept the ARP and respond directly with station B's address if it's known. Let me get to the unknown case in a moment, at which point A will forward the data directly to station B via the switching interface, rather than via a frame processing or routing interface. Okay? Now this is in the case where the direct IP switch knows already how to get to station B. This is the fastest case. Okay? However, at the very beginning, the direct IP switch doesn't know anything. So we have a very simple extension where the direct IP switch will simply ask for station B's hardware address. Station B, of course, will respond to the direct IP switch's request. The direct IP switch will then be able to forward the answer back to station A. And now station A and station B will communicate exactly as if there was no direct IP switch, okay? Layer 3 switching in general, okay? So this is basically the process of direct IP. And you can see that it performs a similar task to the function of a router in a different way and much faster, okay? Now, let me talk a little bit about direct IP security before I talk about how this compares a little bit in more detail and how to configure the network. So let's talk about security. Now on a router, typically at bare minimum, you have the capacity to say that IP address X can't talk to IP address Y. Subnets, addresses, whatever you want to call these X and Y, you are allowed to say on a router that this conversation can't happen, a gateway type of behavior. Typically on a router you have many more options. On direct IP, this is also the capability we provide. Okay? So let me show you a little bit about how it works, and I'll use the same diagram I had before. It's actually very, very simple. What we do is, again, we have station A, we have the direct IP, and station B. Okay? Now again, the first thing that happens, of course, is that station A issues an ARP for station B. Okay? The direct IP switch actually, before responding to the ARP, will check its security table. For conversations between A and B at this point. Okay? If the security table says that A is not allowed to speak to B, then the direct IP switch will simply drop the ARP request. Okay? Then, from the point of view of this station, B does not exist. Okay? Because no answer comes back for its ARP request. Okay? So if no, we simply drop the request. If yes, in other words, if they are allowed to communicate based on the security information, okay, then we process as I described a moment ago. Direct IP switch will send an ARP for station B will respond, and the direct IP switch will respond with the hardware address of station B. Now notice that this part of the behavior involves the direct IP switch. Once we get to here, there's no longer any involvement of any kind. Okay? So the software located on the direct IP switch only interacts with ARP frames. The data doesn't touch the software. Okay? That allows a very quick hardware forwarding path, just as normal switch data, even though we're going from subnet to subnet. Okay? Now, how do we configure this security? Well, we allow a variety of combinations. Basically, the simple description is we say IP1 mask 1, IP2 mask 2, and basically accept or deny. Okay? Now why do we do that? Because, for example, we can say that the subnet, for example, 192.168.1.0 with a net mask of 255.255.255.128, for example, cannot talk to the subnet 192.168.1.128. We can say that this conversation is prohibited. Okay? But we can have a second entry, for example, for a particular host. For example, 192.168.1.1 may communicate with 192.168.1.129. And you see that this violates this. Okay? But since this is a stronger net mask, this entry takes precedence over this entry. So you see that we can say subnets can't communicate, but hosts can communicate outside of those rules. Okay, so we provide quite a bit of flexibility, and we allow you to set whatever net mask you want here for any entry. So you have complete control basically over subnets, host communications. You can say host A can speak to subnet B, or host A can't speak to subnet B, etc., etc. Anything like that. Okay, and again, all of it is handled during this process. Configuring a network to operate on direct IP. This is a very simple concept where, again, all you need to know is this connection, where the original ARP from A is addressed directly to B. Okay, this is the key to understanding how to configure your network for direct IP. Because this station A must know how to issue an ARP directly to this station B. Okay? And in general, there are two ways of doing that. So number one, we can use subnet mask to put these two hosts on the same subnet. Okay? But notice that the direct IP switch is doing all sorts of broadcast filtering here, and also is doing security.
Also,
So,
can the front desk also, front desk please?
so while we're using the same subnet, as far as the hosts are concerned, we actually have security, and we also have broadcast protection. Okay? These are the two features desired in a router. So you see that by using direct IP, we can provide the same services that a router provides at the speed of a switch. Okay? The same service is performed on the network. Okay, including security, including broadcast protection, everything we need to have. So this is one way of doing this, is to use a subnet mask. A second way of doing it is basically to configure a host to what we call truly flat. Okay? And depending on the type of host, there are several different methods by which one can do this, and when I get to DHCP, I'll explain a little bit more about this. But for example, what we can do is set the gateway, for example, on Win95. If the gateway is set to the host IP, then Win95 treats the whole network, everything, all IP addresses, as local. Okay? Which means that regardless of what the subnet configuration is of the rest of the network, this station, if configured like this, will always send an ARP to the destination. Okay, so you see that this is a second way of generating the necessary configuration. Okay? In general, we prefer, of course, using a standard setup with the network. However, in certain cases, it is also useful to do this sort of thing. Okay. So let me talk a little bit about how direct IP interacts with routing based on this information. the first question on everybody's mind, of course, is can direct IP and routing interoperate? Okay? The answer is yes. Okay? Absolutely. Now, there are several places on the network where you might find a router. So let me give one simple example. Let us say that I have a WAN router connected to a direct IP network. Okay? This is one example. Okay, this is actually the simplest example because actually the presence of this router does not affect the rest of the network at all. Okay? Why? Because if I have a host, I simply set the WAN router as the default gateway, as I normally would. Okay? And I configure the network locally, as far as the hosts are concerned, to be one flat subnet. But the remote part of the network will obviously be on a different subnet, any number of different subnets. So the local network, the hosts will go through the direct IP switches, as I described before. To get to the WAN, the default gateway will be used. Okay? Now let me describe a little bit about this interaction, but it's very straightforward and operates exactly as one would expect. If I have a router connected to a direct IP switch, the only impact is that the direct IP switch has to know that this is a router, as opposed to another direct IP switch. Okay? So when configuring the routing tables of this direct IP switch, he only has to know that his default gateway is a router. Now, how does this work? For example, let us say I have a host A and a host B and a host C. Okay? When host A needs to transmit to host B, as we recall, the configuration of the network is such that A will ARP B directly. Okay? This is a logical diagram. Okay? Physically, what happens, host A ARPs B via the direct IP switch. The direct IP switch processes security. If the security is passed, it forwards the request to the next direct IP switch. Okay? He does the same thing. Finally, the ARP gets to the station, the response bounces back, and then the data flow starts normally. Okay? Now, when host A wants to transmit to station C, he sees that station C is actually across on a different subnet. So what he does is ARP his default gateway, as I described before. So station A will ARP the router interface. Now, the router interface at this point looks exactly like another station on the network. So host A will ARP the router via the direct IP switch. The direct IP switch will behave the same. Okay? The ARP will come back from the router to the station, and the station will send frames directly to the router, as it would in a normal network, but to the IP address of the end station. Okay? Exactly as normal. So the data flow goes through the router exactly as it would if the direct IP switches were not even there. Okay? So everything works in a very simple and straightforward manner. So this is one example where there is a WAN connection and a direct IP side of the network. Okay? Another example is, what if we want to have two direct IP networks interfacing across a router. Okay? Depending on the particular network requirements, this might be a necessity. Okay? If you need more features on the router, for example, than direct IP offers, socket protection, things like that. Okay? First of all, again, this is very simple because it's a very logical extension of the previous example. So we see that to get out to here, there's actually no difference. Station A knows the IP of station B and knows that it's remote, and knows that the route is towards this router. So station A will ARP the router and then send data directly to the host via IP, but of course via Ethernet the data will go towards the router. The router will of course perform the same task. The router will ARP station B. It's the same process, only in reverse, so there's no difference in behavior. And I've already described how one station ARPs another station through a sequence of direct IP switches. So you see that the router ARPs station B. Station B responds to the router, and the router in station B can then send packets. And now the data flows through the router as normal, as if the direct IP switches were not there. Okay? But notice that we have an additional feature on our network because the direct IP switches are there. What is that feature? Well, we have broadcast protection between different direct IP subnets. That's one feature. And another feature is that we have security inside of these clouds. Not just at the router, where we also have security, but we also have security at the direct IP clouds and broadcast protection. So you see that on a larger network, you can have several direct IP switches spread out on various branches of a router and perform the same function on that network as a huge sequence of routers would normally perform. Okay? So you get the same behavior on the network, very similar features, at a much higher performance and a much lower cost than a router can typically provide, which is exactly the function of direct IP. Okay? The only caveat to this whole description is that this router interface and this router interface must think that this direct IP network is just one big flat network. Okay? Which is a very simple thing to configure. Okay? Again, the router behaves as if the direct IP switches are not there. But the direct IP switches provide extra functionality over a normal switch. Okay? And whether you have a router here or not, you still gain all of the functionality that you need from a router inside of your local network. So that's how routing and direct IP interact. Now let me talk a little bit about DHCP. DHCP is a standard protocol. It's an extension of the BootP protocol, which I have described before, which stands for, I believe, Dynamic Host Configuration Protocol, something similar to that. The purpose of this protocol is you have a pool of IP addresses, okay? And I have a host on my network, some host with some MAC address, unknown. This host requests the DHCP server to give an IP address, any IP address. So the server picks one and sends it back. Okay? The obvious advantage of DHCP is that you can buy a computer, plug it into the network, turn it on, and it immediately can connect to the rest of the network without having to worry about assigning it an address in any lookup tables or anything like that. This is the obvious advantage of DHCP. But as it applies to direct IP, there's another advantage, which is that we can use DHCP to configure the entire network from a single server or a single set of servers. So for example, suppose I have a direct IP network and I have several hosts, and let's say that I'm on subnets A, B, C, D, E, etc. And on this network I dedicate a port to a machine which is a DHCP server. One port on the whole network reserved for the DHCP server. Okay? Now inside of here I have some connections between devices. Okay? Now these hosts, when running DHCP, will send a broadcast to find a DHCP server. The direct IP switch can be configured to redirect this DHCP message to the actual DHCP server, but with the information which subnet the request originally came from. Okay? So I can have on my DHCP server a pool for A, a pool for B, a pool for C, a pool for D, and a pool for E. So if I have a host over here that sends a DHCP request, the request will be forwarded to the DHCP server. An address will be allocated out of pool A, the correct pool, obviously, and sent back to the host. Okay? What this allows you to do is keep the configuration of your network centralized to one or several DHCP servers. The obvious advantage is that the entire network can be configured very easily. Another advantage is that the addresses can be modified. In other words, I can eliminate a subnet, move a subnet onto a different subnet, etc., simply by rearranging the configuration of the direct IP switch and the DHCP server, but not by touching the host. Once the hosts get a new IP address, it will be from the new allocated pool, and the host will then immediately move to a different subnet. Okay? This is another advantage of DHCP. There's one other advantage that we can gain by using DHCP, actually two other advantages. One of them is, remember I said we have to configure the network. Now configuring the network means assigning the correct subnet masks, things like this. So that configuration is done in the DHCP server. And the DHCP server spreads the configuration to the network. Rather than sitting at each host and making the configuration what it needs to be, we simply configure the DHCP server. And if we need to change the configuration, the changes will take effect. Another added feature is, as I mentioned before, there are certain cases where it might be useful to modify the DHCP response. Okay? Now what do I mean by this? Remember I said a moment ago that under Windows 95, for example, if the default gateway is equal to the host IP, then the Windows 95 machine will assume that the whole network is flat. Okay? Which is a useful way of configuring a direct IP network. Not the only way, but a useful way. So we actually have built into our direct IP a tool which, when enabled, will perform this operation. Okay? So the DHCP server can be configured normally, and the direct IP will simply intercept the response, modify the gateway in the frame, and send the response back out to the host, and the host configuration will then be matching this. Okay?